So let us consider f of t is equal to u of t plus iv of t. We know that f of t is a complex function. That's why we can write f of t equal to u of t plus iv of t, where t is a point between a comma b, where u and v are real valued functions of t in closed interval a comma b. We define the integration to the f of t as integral a to b f of t dt is equal to integral a to b u of t dt plus I integral a to b v of t dt, where integration of a to b u of t dt is real part of integral a to b f of t dt, and integral a to b v of t dt is an imaginary part of integral a to b f of t dt. Now going to the definition for the continuous arc. A set of points x comma y such that x is equal to x of t, y is equal to y of t, where t is between closed interval a comma b, where x of t, y of t are continuous functions of a real variable t. All of you know the definition for the continuous function. Limit z tends to z naught, f of z is equal to f of z naught. Then f of z is continuous at z is equal to z naught. So same is applicable for the x of t, y of t. Then these two functions are continuous of the real variable t is called continuous arc. Next we will discuss about Jordan arc. If no two distinct values to the t corresponds to the same point x comma y, then the arc is called Jordan arc or Jordan curve. If x of a is equal to x of b, y of a equal to y of b, and if no two other values of t corresponds to the same point x comma y, the continuous arc is simple closed curve. Means that if the curve is start at a and end at b, both the points are equal, then that curve is simple closed curve. A simple closed curve is also called Jordan curve. If x of t, y of t having continuous derivatives which do not vanish simultaneously for any value of t, then that arc has a continuously turning tangent. Then the arc is said to be smooth. The length of the smooth arc is L is equal to integral a to b under root of x dash of t whole square plus y dash of t whole square dt, where x dash of t is equal to dx by dt, y dash of t is equal to dy by dt. Next we will discuss about what is a contour. A contour is a continuous chain of a finite number of smooth arcs. Already we discussed the smooth arc here. Now continuous chain of smooth arcs are called a contour. And going to the closed contour. If a contour is closed and does not intersect itself, then it is called a closed contour. Now first topic in the complex integration is line integral. If you integrate a function f of z with the variable with complex variable defined in the domain D, let C be an arc in the domain joining from z is equal to alpha to z is equal to beta. Let C be defined by x is equal to x of t, y is equal to y of t. T is a point between closed interval a comma b. Alpha is equal to x of a plus I y of a. Beta is equal to x of b plus I y of b. Both alpha and beta are complex variables. Let x of t, y of t having continuous first order derivatives in closed interval a comma b. We define the integration for f of z is integral c. C is a arc. We know that this c start at z is equal to alpha and at z is equal to beta. Integral over c f of z dz is equal to integral t equal to a to b. Here x and y are depending on ab, and ab t is between ab, so that's why we can take t is an independent variable and AB are depending on t, so that's why we can take t equal to a to b f of x of t plus I v of t into x dash of t plus I y dash of t into dt. How to get this one? We know that z is equal to x of t plus I y of t, and dz is equal to dx plus I dy, and differentiate z with respect to t, dz by dt is equal to dx by dt plus I dy by dt. That is, dz is equal to dx by dt plus I dy by dt into dt. So why the integration limits are a to b for t, so that's why total integration right in terms of t, integral function right in terms of t. That's why we can write x dash of t plus I y dash of t into dt. So the steps involving in the line integral is, first step is you have to take z is equal to x plus iy and dx is equal to x dash of t comma y dash of t, dy by dt is equal to y dash of t. And we know that dz is equal to dx plus I dy, and multiplying with the t we can get the dt, dx by dt plus I dy by dt into dt. Then dx by dt is equal to x dash of t, dy by dt is equal to y dash of t. And the second step, let f of z is equal to u of x comma y plus iv of x comma y. Substitute x is equal to x of t, y is equal to y of t. F of z is equal to u of x comma t, x of t comma y of t plus iv of x of t comma y of t, where f of z is equal to u plus iv. We know that where u, v are functions of t. Step 3. Integral c f of z dz is equal to integral t equal to a to b u plus iv into dx plus I dy. So here f of z is equal to u plus iv, we know that, and dz is equal to dx plus I dy, we know that. But the integration is depending on t, so that's why we can convert into t by multiplying these two terms and separate the real and imaginary parts. After that we can take integral t equal to a to b u of u into x dash minus v into y dash into dt. If you write dx by dt, dy by dt into dt, it becomes to x dash of t and it becomes to y dash of t. Then simply we can write x dash and y dash, and here also we can write y dash x dash because of dy by dt and dx by dt into dt. So this is the main formula to find the line integration. Integral c f of z dz is equal to integral t equal to a to b u plus iv into dx plus I dy. Last step is integral c f of z dz by evaluating the two integrals on the right hand side. Integral c f of z dz is also called a contour integral. If the contour c is traced from t equal to b to a, the value of the integral will be minus 1 times the above integral, that is minus of integral b to a u plus iv into dx plus I dy. Now we will discuss the examples on line integration. So first example is evaluate integral c z square dz, where c is the straight line segment from 0, z is equal to 0 to a, z is equal to 2 plus I. The solution is, let us find the parametric equation to the curve C, that is straight line segment O, where O is equal to 0, 0 and A equal to 2, I. How to get the 2, I? Z equal to 2 plus I, comparing with x plus iy. X quadrant is 2 and y quadrant is 1. Identify the point 2 plus I. On x-axis value is 2 and y-axis value is 1. We can identify the point here and draw the straight line from O to A. Now we can find the integration to this line segment by using the equation of straight line. So equation of the straight line is y minus y1 is equal to slope into x minus x1. What is the formula for this slope? y1 minus y2 by x2 minus x1. y2 is 1, y1 is 0. 1 minus 0 by x2 is 2 and x1 is 0. 2 minus 0. That value is 1 by 2. And now we get the equation for this straight line. Y is equal to x by 2. That is x is equal to 2y. Dx is equal to 2 dy. So now our total integration change into variable y. How to get the integration to the given function z square dz is substitute all the values for the x, y. So that is z square dz is equal to, all of you know z is equal to x plus iy whole square. Dz is equal to dx plus I dy. Then multiply these two terms, we get the real and imaginary parts like x square minus y square into dx minus 2xy dy plus imaginary part is I into 2xy dx plus x square minus y square dy. All of you know the real into imaginary is imaginary, imaginary into real is imaginary. Now real into real is real, imaginary into imaginary is also real. So we are using that, then simply we can multiply and separate the real and imaginary parts. We get z square dz is equal to x square minus y square dx minus 2xy dy plus I into 2xy dx plus x square minus y square dy. After that we are substituting x is equal to 2y and dx is equal to 2 dy. So now substitute the values. X square is equal to 2y whole square 4y square minus y square and dx is 2 dy. Next 2y into x value is 2y into dy. Next 2y into x value is 2y and dx is 2 dy. Next here x square 4y square minus x value is 2y 4y square minus y square into dy. Now after simplification we are getting 2y square dy plus I into 11y square dy. Here simply you can integrate the function y square, take the common, 2 plus I11 is a constant right outside. Y square integration is y cube by 3, limits are 0 to 1. How to take the y limits? Because of our given function totally change into y, so that's why we can take the integration limits for y. Here the lower limit is 0, 0 and upper limit is 2, 1. Then from that we can take the y limits. Y limits are 0, 2, y quadrant is 1. So that's why y limits are 0 to 1. Then we can substitute the y value. We get upper limit is 1, 1 by 3 minus 0. That's why 1 by 3 into 2 plus 11i is the answer. We are going to discuss about the next example. Evaluate integral cy minus x minus 3x square I dz, where c is of the line segment from z is equal to 0 to z is equal to I, and the other from z is equal to I to z is equal to 1 plus I. Let A represent z is equal to I and B represent z is equal to 1 plus I. The curve C is the combination of OA and OB. Here they give the two line segments, that is first line segment from z is equal to 0 to z is equal to I. If you compare z is equal to I to x plus iy, x quadrant value is 0, y quadrant value is 1. So that's why the point 0, 1. And going to the other form, and the other from z is equal to I. Z is equal to I is this point 2. Z is equal to 1 plus I. So here x quadrant value is 1, y quadrant value is also 1. So that's why the point is 1, 1. So how to identify 1, 1? On x axis 1 and y axis 1. So this is the point 1, 1. So first line segment is OA, other line segment is AB. So integral CF of z dz is right as the addition of two integrations or combination of two integration, that is integral OA f of z dz plus integral AB f of z dz. So here f of z dz is equal to y minus x minus 3x square I dx plus I dy. Along OA, x is equal to 0, y is equal to t, we can take 0 less than or equal to t less than or equal to 1 here. So equation is not given, so that's why we are changing into t. So that is integral OAF of z dz is equal to integral t equal to 0 to 1 t. Why? Because of y is equal to t, and here dy is equal to dt, so that's why we can write here dx is x is equal to 0, dx also 0, and y is equal to t, dy is equal to dt. So we can substitute here, we are getting I into t square by 2, t integration is t square by 2, limits are 0 to 1, so the value is I by 2. Next, along AB, y is equal to 1, x is equal to t. So that is 0 less than t less than 1. So that's why integral a to b f of z dz is equal to integral t equal to 0 to 1, 1 minus t minus 3t square. Because of here y value is 1 and x value is t, we are giving the limits to the t 0 to 1. 1 to 1 minus t minus 3t square I into dt. Then we are getting the integration for this is integral dt is t integration is t square by 2, and 3 into t square integration is t cube by 3. 3 cancel, t cube I limits are 0 to 1. We are getting the value is 1 by 2 minus I. So what is the contour integration? Integral c f of z dz by using line integral is, we can add these two, I by 2 plus 1 by 2 minus I. After simplifying, we are get 1 minus I by 2. So why we convert into t in this sum is, here two line segments are there. So here the first point O is 0, 0. Next point A is 0, 1. So here clearly 2 points, x value is 0, y value is 0 to 1. But if you convert into y, then we can take into directly y, and y limits are 0 to 1, x you can substitute it into 0, dx is equal to 0, and dy is as it is, we can write directly. Otherwise we can convert into t, y is equal to t, you can take the limits for t limits are 0 to 1. And going to the AB also, here A point is 0, 1, B point is 1, 1. So here clearly we can we know that here y value is 1. This is a line segment for y equal to 1, so that's why y is 1, and x is from 0 to 1. Directly you can take the x, dx, and x limits are 0 to 1. Otherwise you can convert into other variable, that is t between 0 to 1. Then we can find the integration. Next problem is evaluate integral c x minus 2y dx plus y square minus x square dy, where c is the boundary of the first quadrant of the circle x square plus y square is equal to 4. So we have to find the line integration, but here the given region is given, curve is x square plus y square is equal to 4. It's a circle equation. So that's why we can convert into polar form. It is easy to get the integration. So that's why we can convert into the polar form by using parametric equations of the circle. X square plus y square is equal to 4 by substituting x is equal to r cos theta. Here r is equal to 2 because of the equation of the circle is x square plus y square is equal to r square. So that is x is equal to 2 cos theta. R square is equal to 4. R is equal to 2. So that's why x is equal to 2 cos theta. Y is equal to 2 sin theta. And obviously the circle means the angle is 0 to 360. So that's why theta limits are 0 to 2 pi. And going to the dx is equal to, here we need to substitute dx value, dy value also. So that's why we can find dx is equal to 2 is a constant, cos theta integration is minus sin theta, theta integration is the d theta, and dy is equal to 2 constant, sin theta derivative is cos theta d theta. Next, we have to substitute all the values in this equation given integral 0 to pi by 2 cos theta minus 4 sin theta minus dx is equal to minus 2 sin theta d theta plus 4 sin square theta minus 4 cos square theta, dy is 2 cos theta d theta. After simplification, we get minus 4 common and write the integration to each and every term separately, that is 0 to pi by 2 sin 2. Here you can write 2 into means 2 sin theta cos theta is equal to 4 is a common value, so that's why we can write outside. Here multiply and divide with 2, we can write 1 by 2 into 2 sin theta cos theta is sin 2 theta d theta, and sin square theta is equal to, we know the formula is 1 minus cos 2 theta by 2, 2 get cancelled, and next one 2 sin square theta cos theta, then d theta, and next last one is cos cube theta. We know the formula for cos 3a. By using that formula we can write cos 3 theta plus 3 cos theta by 4 into d theta. So after is all of you know the integration for sin theta minus cos theta means minus, here x theta is there, so that's why we can write a theta is there, that's why write constant in the denominator. So minus cos 2 theta by 2 into 1 by 2, it so becomes to 4, 0 to pi are the limits. 1 minus cos 2 theta, integration of d theta is theta minus sin cos 2 theta integration is sin 2 theta by 2, limits are 0 to pi by 2. Next minus 2. Here why I write the sin cube theta by 3, because of if you take sin theta is equal to t, so in derivative of sin theta is cos theta d theta, means here f integral f power n of theta into f dash of theta d theta. Otherwise simply we can discuss the problem is integral f dash of x into f of x dx, f power n of x into f dash of x dx equal to, we can write f power n plus 1 of x by n plus 1. By using that formula, I am writing the value is sin power 3 theta by 3, limits are 0 to pi by 2. And next one is here we can write 2 by 4, it's a 1 by 2. Sin 3 theta is cos 3 theta, integration is sin 3 theta by 3 plus 3 into cos theta, integration is sin theta, limits are 0 to pi by 2. Now we can substitute the limits. Then we can, upper limit is pi by 2 and lower limit is 0. Here if you substitute pi by 2 for the theta, we get cos pi value is minus 1, cos 0 value is 1. So here also pi by 2, sin pi value is 0, sin 0 value also 0. So next here also sin pi by 2, so 1 whole cube by 3 minus lower limit is 0. Next plus 1 by 2 into sin 3 theta, sin 3 pi by 2 value is minus 1. So then minus 1 by 3 plus sin pi by 2 value is 1, lower limit is 0. Then if you simplify that, we can get the value is 2 pi minus 14 by 3. The next sum in the line integration is evaluate integral 0 to 1 plus I. Here 1 plus I, here they gave the limits directly with the equation of x plus iy form, 0 to 1 plus I and x square minus iy dz along the path y is equal to x. Y is equal to x is a straight line passing through the origin, and y is equal to X square is a parabola symmetrical about y-axis. Next, given integral is integral 0 to 1 plus I x square minus I y dx. If you take the first path, so dy is equal to dx, and along first we have to identify the points. First, lower limit is 0 and upper limit is 1 comma 1, and the path is y is equal to x. So this is called OB. So along OB, whose equation is y is equal to x, dy is equal to dx. X varies from, we know that 0 to 1, x varies from 0 to 1. So total equation is changing into x, so that is x limits are 0 to 1, x square minus y is equal to x, dz is equal to dx plus I dy, so dx plus I dx. So here dx common, 1 plus I is a constant right outside, and you can integrate that. X square integration is x cube by 3 minus I into x integration is x square by 2, limits are 0 to 1. If you substitute it, we get 1 plus I into 1 by 3 minus I by 2. Next, going to next path. Along the parabola whose equation is y is equal to x square. So dy is equal to 2 dx. So along OC means that this is a curve, so that's why we can call as OC. Y is equal to x square. X square minus IY into dz becomes 2. We are substituting y is equal to x square. So x limits are 0 to 1. That is x is equal to 0 to 1. So how to get this 0 to 1? They give the point integral 0 to 1 plus I. So that's why we can take x is 0 to 1, y is also 0 to 1. So but here our integration is changing into x terms. So that's why we can take x is equal to 0 to 1 x square minus I into y value x square dx plus I into dy value is 2 into d sorry, here 2x dx, x is missing, so 2x dx. Then 1 minus I is constant, common x square, multiply with this term, we can get x square plus I into 2x into x square, 2x cube. So 1 minus I, x square integration is x cube by 3 plus 2I into x cube integration is x power 4 by 4. Limits are 0 to 1. So then substitute the limits, 1 by 3 plus 2I into 1 by 4. It is I by 2. So next one is evaluate integral c y square plus 2xy dx plus x square minus 2xy dy. C is the boundary of the region y is equal to x square and x is equal to y square. These two are the parabolas. One is symmetrical about x-axis, one is symmetrical about y-axis. So x is equal to y square is symmetrical about x-axis, y is equal to x square is symmetrical about y-axis. So first we have to find the intersecting point of these two curves. How to find the intersecting point of these two curves? We can solve these two equations, then we can get the intersecting point. So how to solve it? If you substitute x is equal to y square, we get y is equal to y power 4, then y minus y power 4 is equal to 0, then we can get y common, y into 1 minus y cube is equal to 0, y is equal to 0, y is equal to 1. So if y is equal to 0, x is equal to also 0, so that's why first intersecting point is 0, 0, and other one y is equal to 1, x is equal to also 1, other intersecting point is 1, 1. That's why here we write two curves intersect at 0, 0 and 1, 1. First path is y is equal to x square. Along y is equal to x square means here clearly we know that x limits are 0 to 1, y limits are 0 to 1. So that's why you can change into any terms, x terms or y terms. But here we are changing into x terms, that is y is equal to x square, dy is equal to 2x dx. X varies from 0 to 1. Integral 0 to 1, we are substituting the values. Y is equal to x square, so that's why x power 4 2 into x cube dx plus x square minus 2x into x square 2x cube, and dy is 2x dx. So here total limits are from 0 to 1, so that's why I write for 1 integration, and simplify that. Dx is common, we get minus 3x power 4 plus 4x cube. Then integrate that. X power 4 integration is we can get x power 5 by 5, and x cube integration is x power 4 by 4. 4 cancel, and substitute the upper limit. 1 minus 3 by 5 value is 2 by 5. Next, along y square is equal to x. So here we can convert into y, so that's why we can take dx is equal to 2y dy. Y varies from 0 to 1. Already we discussed x varies from 0 to 1 and y varies from 0 to 1. So we can convert into y terms and simplify that. We can get 5 y power 4 dy. Then y power 4 integration is y power 5 by 5. Limits are 0 to 1. We get the solution is minus 1. Integral over cf of z dz is equal to, we can add these two values because of the curve, the region is between two curves, so that's why we are finding the line integration through OA, along OA and along AO. So along OA, along AO, we need total integration, so that's why we can add both. 2 by 5 minus 1, so the answer is minus 3 by 5. So that's all, students. Today we will discuss about line integration. In the next class we will discuss about Cauchy's integral theorems.